Welcome to these gentle, soothing stories for sleep. I am so glad that you are here. Whether you are preparing to drift off into slumber, relaxing after a long and trying day, or simply seeking a quiet and thoughtful companion in the stillness of this moment, you have found a safe and peaceful place. Tonight, we will begin a journey together, an exploration into a question that is at once simple and immeasurably deep, a question about the very nature of the light that fills our world and our universe. Before we begin, I would love to know where you might be listening from this evening, or perhaps just how your day has been. Please feel free to leave a gentle comment below. Wherever you are, I hope you are feeling comfortable, supported, and ready to explore something both gentle and extraordinary. And if you find these soothing scientific journeys to be a pleasant companion or a welcome moment of peace, please consider liking this video and subscribing to the channel. It truly helps more souls who are searching for quiet and wonder to find their way here. Imagine, if you will, the last warm sliver of the sun as it dips below the distant horizon. That final, fleeting warmth that you feel upon your skin, that last glint of golden light that catches your eye. Did you know that it is a ghost? It is a beautiful, warm, and lingering phantom. As you settle into your comfortable space, let your mind drift to the scene of a perfect sunset. You can feel the air beginning to cool around you, a gentle shift from the energy of the day to the quiet embrace of the evening. The sky, just moments ago a brilliant and piercing blue, has begun to bleed into a soft palette of orange and pink and a deep, royal purple. The light is no longer direct and sharp, but has become diffuse and soft, wrapping itself around the edges of the clouds and the silhouettes of the trees. It is a light that feels ancient and full of story, a final, long exhalation from the star that gives us life. You feel that last touch of warmth on your cheek, a final, tender kiss goodnight from the sun. It feels immediate, perfectly present, a moment shared between you and that great, distant star. But the truth is, this moment is a beautiful illusion, a trick of time and distance. The light that is painting the clouds and warming your skin began its journey long before it reached you. In the vast, silent emptiness of space, this light has been traveling tirelessly across approximately 150 million kilometers of nothingness to complete its journey in your eyes. And this journey, even at the most incredible speed the universe allows, is not instantaneous. This is our first piece of quiet knowledge for the evening. Light, for all its seemingly magical and instantaneous quality, takes time to travel. From the surface of the sun to the surface of the earth, that journey takes, on average, 8 minutes and 20 seconds. So when you witness that final, breathtaking moment of the sun disappearing completely from view, when the last edge of its fiery disk slips below the curve of the earth, the sun itself had already physically set 8 minutes and 20 seconds ago. The image you are seeing, the light you are feeling, is an echo. It is a message from the recent past, a postcard that has been in transit, delivered to you just now. The warmth on your skin is the ghost of a sun that has already moved on from its position in the sky. This is not just true for the sun. It is true for everything you see. When you look at the moon, shimmering in the night sky, you are seeing it as it was just over 1 second ago. The light has to travel across the 384,400 kilometers of space between us, a journey that takes about 1.28 seconds. It is a very small delay, imperceptible to our senses, but it is real. The moon you see is always the moon of a moment ago, and the farther we look, the deeper into the past we gaze. The light from Jupiter takes over half an hour to reach us, while the light from the beautiful, pale stars that form the constellation of Orion began its journey hundreds or even thousands of years ago. The starlight that greets you on a clear night is an ancient traveler, carrying a story from a time before any of us were born. Let us reflect on this for a moment. Every single glance we take, every observation we make of the world around us, is an act of looking into the past. Our reality is a delicate and intricate tapestry woven from these delayed messages, a collage of different moments in time all arriving at once. We are always, in every moment, living in a history that is constantly being updated. There is no universal, simultaneous now. When you look into the eyes of a loved one across a room, you are seeing them as they were a few nanoseconds in the past, the time it took for the light to travel from their face to yours. It is a profound and subtle truth that we are separated from the true present by the time it takes for its story to reach us. The entire universe we perceive is a historical document, and we are its gentle readers. That warm, golden messenger from the sun travels impossibly fast, faster than anything else we have ever known, moving at a speed so immense it is difficult for our minds to truly comprehend. But it is not instantaneous. It has a limit. And this simple fact begs a wonderfully deep question. Why would the universe, in all its infinite grandeur, impose a speed limit on its most fundamental and swift-footed courier? Have you ever found yourself sitting on a covered porch during a warm summer storm, patiently counting the seconds in the quiet interval between the brilliant flash of lightning and the deep, rolling boom of the thunder? It is a timeless, almost meditative act, a simple piece of childhood science that connects us to the raw and beautiful power of the natural world. Let us drift into that scene together now. The air is thick and heavy with the promise of rain, carrying that unique earthy scent that rises from the dry ground, a fragrance known as petrichor. A sense of anticipation hangs in the stillness. Then, without warning, the entire world is bleached of color for a fraction of a second. A sudden, silent, and intricate web of white-hot light tears across the bruised purple sky, illuminating every leaf on every tree, every blade of grass, in stark and beautiful detail. It is a moment of pure, silent spectacle. And then, the waiting begins. 1, 2, 3, 4. You count the seconds, feeling the quiet rhythm in your chest. And just when you think the sound might never arrive, you begin to feel it more than hear it. A low, distant grumble that grows steadily into a profound, soul-shaking roar. The sound washes over you, vibrating through the floorboards, rattling the window panes. A deep and ancient groan from the heavens that reminds you of the immense energy that has just been unleashed. The story of the storm arrives in two separate parts. First the vision, then the voice. This familiar and powerful gap between seeing the lightning and hearing the thunder provides us with a beautiful and intuitive way to understand the profound difference between the speed of light and the speed of sound. Sound, like a ripple spreading from a stone dropped into a calm pond, needs a medium to travel through. It is a physical vibration, a pressure wave that travels by compressing and decompressing the molecules of the substance it is in this case, the air. The speed of sound depends entirely on the properties of that pond, on the density and temperature of the air it is pushing through. In the air at sea level, sound ambles along at a respectable pace of about 343 meters per second, or roughly 1,235 kilometers per hour. Light, however, is a completely different kind of traveler. It is not a pressure wave pushing its way through a substance. It is an electromagnetic wave, a self-propagating disturbance in the fundamental fields of the universe itself. It requires no medium. It does not need the air, or water, or anything at all to carry it. It can travel, and indeed travels fastest, through the perfect, empty vacuum of space. While the sound of the thunder is laboriously pushing its way through the thick, humid air, the light from the lightning flash arrives in your eyes almost instantaneously, for all practical purposes. Its speed is so vastly superior that the journey over a few kilometers is completed in mere microseconds. We can see how our senses work together to build our perception of reality, constructing a single story from these two messengers that arrive at such vastly different times. The delay between the sight and the sound creates a moment of natural suspense, a small narrative arc written by the storm itself. It tells us that the universe is not just about what happens, but about when the information of what happened arrives to us. This simple observation, this counting of seconds on a rainy evening, is a direct experience of the universe's different speed limits. We can intuitively grasp why sound has a speed limit. It is limited by how quickly it can push the air molecules out of its way. It is like trying to run through a dense crowd of people. Your speed is limited by how quickly you can navigate through the obstructions. The denser the crowd, the slower you go. Sound travels faster in water than in air, and faster still in a solid like steel, because the molecules in those substances are more tightly packed and can transmit the vibration more efficiently. But this only deepens the mystery of light. If light travels through the perfect emptiness of space, a place with no crowd, no obstructions, no molecules to push out of the way, what could possibly be holding it back from having an infinite speed? What is the air for light that it must push against? What is the source of its friction, the cause of its ultimate, universal speed limit? Imagine holding your hand out in a gentle spring shower, feeling the distinct, separate plink of each individual raindrop as it lands in your palm. Each one is a tiny, self-contained sphere of water, a discrete little package of moisture arriving on its own. Now, shift your thoughts to a warm ocean and recall the feeling of a powerful, rolling swell lifting you effortlessly off your feet. This is not a collection of separate impacts, but a single, unified surge of energy, a continuous wave of immense and flowing power. The raindrop is a particle, the wave is a disturbance. They feel like two fundamentally different, even opposite, phenomena. But what if light, the very essence of seeing, was somehow, impossibly, both of these things at the exact same time? This is one of the deepest and most beautiful paradoxes in all of science, a quiet koan whispered by the universe itself. Let us explore this gentle mystery. Allow your mind to drift back to that light spring rain. You can almost feel the cool, separate kisses of water on your face and hands. There is a clear sense of individuality to each drop. You could, in principle, count them one by one. They are things, little objects following a path from the clouds to the ground. Now, transport yourself to that shoreline. Feel the sand between your toes and watch the rhythmic advance and retreat of the tide. The waves are not a collection of things, but a behavior of the water itself. It is a pattern of energy moving through the ocean, a continuous and flowing form that cannot be broken down into individual pieces. For centuries, the greatest scientific minds were locked in a debate about the nature of light that mirrored this very distinction. Was light a stream of tiny, infinitesimally small particles, like a shower of microscopic rain, or was it a wave, an ethereal tremor propagating through some unseen ocean? The great Sir Isaac Newton was a firm believer in the particle theory, proposing that light was made of what he called corpuscles, and there was good evidence for this. Light travels in straight lines, just as a thrown ball does. It casts sharp shadows, suggesting that particles of light are being blocked by an object. But there was also compelling evidence for the wave theory. Light can be seen to bend around corners, a phenomenon called diffraction, just as an ocean wave bends around the rocks of a jetty. It can also interfere with itself, where two light waves can meet and either amplify each other to create a brighter light, or cancel each other out to create darkness, just as two crossing ripples in a pond can create peaks and troughs. For hundreds of years, the debate raged on, with evidence supporting both sides. The answer, when it finally began to emerge in the early 20th century, was stranger and more profound than anyone had imagined. The universe, it seemed, had no obligation to choose. The evidence for light behaving as a particle is beautifully illustrated by something called the photoelectric effect, a phenomenon Albert Einstein would win his Nobel Prize for explaining. Imagine you have a delicate wind chime hanging in your garden. If you want to make it ring, you could try blowing on it, creating a continuous wave of air. But if you blow too softly, nothing will happen. However, if you toss small pebbles at it, even if you toss them very infrequently, as long as each individual pebble has enough energy, it will make the chime ring. This is what happens with light and electrons on a metal surface. A dim red light, which is a low-energy wave, can shine on the metal for hours and nothing will happen. But the moment you shine even the faintest blue light, which is made of higher energy photons, it will instantly knock electrons loose. This suggests that light arrives in discrete packets of energy, little pebbles of light we now call photons. And yet, the wave nature of light is undeniable. If you shine a light through two very narrow, closely spaced slits, you do not get two simple bright lines on the screen behind them. Instead, you get a beautiful intricate pattern of many light and dark bands, a classic interference pattern that can only be created if a wave passes through both slits at once and interferes with itself. Light, it seems, is both a river of raindrops and a wave in the ocean. This confounding, paradoxical nature, this quantum mechanical truth, is known as wave-particle duality. Our language, built for a world of solid, sensible objects that are either here or there, a thing or a motion, struggles to capture this truth. The universe does not have to obey the limits of our vocabulary or our imagination. And this strange, dual identity is deeply and inextricably tied to its speed, for the way it travels as both particle and wave is at the very heart of why it has a constant velocity and why for so long we searched for an ocean it did not need. When you sit in a darkened room and watch a film, you see a story unfolding before your eyes. You see characters moving, laughing, and living in a world that feels fluid and continuous. But as you may know, what you are actually looking at is a trick, a beautiful and clever illusion. The projector is flashing a rapid succession of completely still, unmoving photographs onto the screen, typically at a rate of 24 pictures for every second of time. In between each of those pictures, there is a moment of complete darkness. Yet you perceive none of it. You do not see the still frames, and you do not see the darkness. Your mind, in its incredible and ceaseless effort to make sense of the world, acts as a silent magician, seamlessly stitching these disparate images together to create the vivid experience of motion. Let us settle into that scene for a moment, the quiet magic of an old-fashioned cinema. You can almost smell the faint scent of popcorn in the air and feel the soft velvet of the seat. The only light comes from the screen and from the projector booth behind you, from which a steady, conical beam of light cuts through the darkness, made visible by the gently dancing motes of dust suspended in the air. You can hear the soft, rhythmic whirring and clicking of the projector, the sound of the illusion being carefully constructed, frame by frame. On the screen, a story flows with perfect, uninterrupted grace, and you are lost within it, completely unaware of the mechanical trickery that is making it all possible. This phenomenon is a window into the hidden work that our minds are doing in every single moment of our waking lives. The information that light brings to us is not processed as a continuous, flowing river of data. Instead, our visual system takes a series of rapid snapshots, much like the frames of a film, and our brain then takes on the role of the master editor, filling in the gaps and smoothing over the transitions to present us with a final, polished product. Our seamless perception of reality. The early theory for this was called persistence of vision, the idea that an image lingers on our retina for a fraction of a second, allowing the brain to blend it with the next one. But the truth is even more complex and wonderful. Our eyes are in constant motion, making tiny, incredibly rapid jumps called saccades. If we were consciously aware of the visual input during these jumps, our perception of the world would be a blurry, nauseating smear. So, the brain does something remarkable. During each saccade, it momentarily blinds us. This is called saccadic masking. For a significant fraction of your life, you are technically blind, but you never notice because your brain cleverly fills in that gap, pasting over the moment of blurriness with information from just before and just after the jump. Our perception of a stable, constant, and smoothly flowing world is therefore a beautiful and masterful illusion, a story that our own neurology tells to us, for us. It is a necessary and helpful lie, a simplification of the raw, chaotic, and disjointed data that our senses are actually collecting. We do not experience the world as it is. We experience a model of the world that our brain has constructed for our convenience. We are all the lead actors in a film that is being directed, edited, and produced inside our own minds. Let us reflect on that for a moment. Our brains are not passive receivers of information from the outside world. They are active, creative partners in the process of perception. They are constantly interpreting, predicting, and, when necessary, fabricating information to build a coherent and useful reality for us to navigate. If our most direct and trusted experience of the world, our own sight, is such a clever and intricate construction, what does that say about the nature of objective reality itself? We are, in a very real sense, the co-creators of the universe we perceive. Our brains work tirelessly to make sense of the messages that light brings. And for the longest time, the greatest minds on Earth struggled to make sense of the messenger itself. They were haunted by a question that seemed, at the time, to be perfectly logical. If light is a wave, what, precisely, is it waving in? Imagine, if you can, an invisible and utterly undetectable substance, a ghostly ocean that fills every conceivable void in the universe. It permeates the space between stars, the emptiness within atoms, and even the very fabric of the room you are in right now. It is a silent, weightless, and perfectly frictionless sea through which our planet and all the heavenly bodies swim without resistance, a completely transparent medium whose only purpose is to carry the gentle waves of light. For a time, the greatest minds in the world did not just imagine this substance. They believed in it with an almost religious certainty. It was a necessary phantom, a logical ghost that simply had to exist. Let us drift back to that time, to the latter half of the 19th century. Picture a laboratory illuminated by the soft, steady glow of gas lamps. The air smells of oiled brass and old wood. Intricate instruments, gleaming with polished metal and finely calibrated dials, sit on heavy oak tables. There is a sense of immense confidence in the air, a feeling that the great discoveries of science have mostly been made, and that the universe is a vast, predictable, and elegant clockwork mechanism. All that remained was to work out the final, fiddly details of its operation. And one of the most significant of these remaining details was to finally characterize this invisible ocean. This substance they called the luminiferous ether. The logic behind the existence of the ether seemed, at the time, to be completely unassailable. Scientists had firmly established that light behaved as a wave, and in their entire experience of the world, from a ripple in a pond to the sound of a church bell, every single wave they had ever encountered needed a medium to travel through. A water wave is a disturbance in water. A sound wave is a disturbance in the air. Therefore, it stood to reason, a light wave must be a disturbance in the ether. This ether had to have some rather magical properties. It had to be rigid enough to support the incredibly fast vibrations of light waves, yet so tenuous that it offered no discernible drag to the planets as they orbited the sun year after year. Despite these strange requirements, its existence was taken as a given. The great challenge was to detect it. And the most ingenious way to do that, they reasoned, was to detect the ether wind. Just as you can feel the wind on your face when you are driving in a car on a still day, the Earth, as it hurtled through space in its orbit, must be moving through this stationary ether, creating a kind of cosmic headwind. This idea gave rise to one of the most famous and important experiments in the history of science, conducted in 1887 by Albert Michelson and Edward Morley. Their instrument was a marvel of precision, an interferometer that split a beam of light into two separate paths that were perpendicular to each other. One beam was sent out and back in the direction of Earth's travel through the ether, while the other was sent out and back at a right angle to it. The analogy would be two equally skilled swimmers racing in a river. One swimmer goes a certain distance downstream and back, while the other swims the same distance across the river and back. The swimmer going downstream gets a powerful boost from the current, but then has to fight against that same current on the way back. The swimmer going across the current is constantly being pushed sideways and has to travel a slightly longer, diagonal path to compensate. A careful calculation shows that the swimmer going across the river will always win this race. Similarly, Michelson and Morley expected the beam of light travelling across the ether wind to arrive back slightly before the beam that went with and against it. When the two beams were recombined, this slight difference in arrival time should have created a telltale interference pattern. They oriented their machine, held their breath, and looked. There was nothing, no shift. No interference. They rotated the entire heavy apparatus, thinking perhaps the Earth was momentarily stationary in the ether. Still nothing. They repeated the experiment at different times of day, at different seasons of the year. The result was always the same. A perfect, stubborn, and resounding null result. The speed of light simply refused to change. This beautiful experiment is often called the most famous failed experiment in history, but its magnificent failure was its greatest triumph. It was a quiet, unassuming execution of a deeply held belief. The ether was a ghost. It wasn't there. Light needed no medium to travel through. This shocking, world-breaking result created a deep crisis in the world of physics. The elegant clockwork universe was broken. One of its most important gears was simply missing. And from the rubble of this failed assumption, an entirely new understanding of reality would have to be constructed. An understanding that would begin not with a ghostly substance that filled all of space, but with the graceful, intimate dance of two fundamental forces. Think, for a moment, of the tiny, surprising spark of static electricity that can leap from your fingertip to a doorknob on a dry winter's day. It is a miniature lightning bolt, a sudden, sharp, and almost mischievous release of energy that you can see, hear, and feel. Now, contrast that with the quiet, unseen, and deeply mysterious pull of a simple magnet holding a note to your refrigerator door. There is no spark, no sound, no sudden event, just a steady, silent, and persistent force. A gentle but insistent grip that you can feel across a small gap of air, but cannot see. For most of human history, these two forces, electricity and magnetism, were seen as entirely separate and unrelated phenomena, two distinct and curious entries in the grand catalogue of nature's wonders. But what if they were not separate at all? What if they were merely two different expressions of a single, unified entity, two sides of the very same cosmic coin? The discovery that this was true would not only revolutionize technology, but would also, quite accidentally, solve the great mystery of the nature of light. Let us immerse ourselves in the distinct character of these two forces. The feeling of an electric spark is one of suddenness. It is a brief, energetic crackle, a release of tension. It speaks of separation, of positive and negative charges that have been pulled apart and are now rushing to reunite. Magnetism, on the other hand, feels like a constant, flowing field. It is the silent alignment of a compass needle with the Earth's pole, a persistent and directional influence that is always present, always active. One feels like an event, the other feels like a state of being. The man who would finally unite these two disparate dancers was a Scottish physicist named James Clerk Maxwell. In the 1860s, through a breathtaking display of physical intuition and mathematical genius, he gathered together all the known experimental laws of electricity and magnetism and synthesized them into a single, elegant set of 4 equations. These equations are, to physicists, what Shakespeare's sonnets are to a poet. They are compact, beautiful, and contain a universe of meaning. What Maxwell's equations revealed was something truly extraordinary. They showed that a changing electric field does not just exist on its own. It invariably creates a magnetic field around it. And, in a perfect, beautiful symmetry, a changing magnetic field invariably creates an electric field. One force could not change without giving birth to the other. Maxwell realized that this meant they could be locked together in a self-perpetuating dance. Imagine an electric field oscillating, which creates an oscillating magnetic field. That oscillating magnetic field, in turn, creates a new oscillating electric field, a little further away, which in turn creates a new magnetic field, and so on. They become a self-sustaining wave of energy, leaping, frogging over each other, creating one another as they travel through space. You might picture this as two dancers holding hands and spinning in a circle. Their intertwined, spinning motion creates a ripple that spreads out across the ballroom floor. The ripple is not moving through the floor in the way a physical object would. The ripple is the propagating pattern of their dance. In the same way, this electromagnetic wave needs no ether to travel through. The changing fields themselves constitute the wave. The wave is the disturbance in the fundamental fabric of spacetime. And here is the most astonishing moment of all. Maxwell used his equations to calculate the speed at which this self-propagating electromagnetic wave should travel. That speed is determined by 2 fundamental constants of nature that had been measured in laboratories. One describing the strength of the electric force in a vacuum, and the other describing the strength of the magnetic force. When he plugged these numbers into his final equation and calculated the result, He arrived at a value of approximately 300 million meters per second. This was a number that was already incredibly famous in the world of physics. It was the speed of light, which had been measured with increasing accuracy for decades. The conclusion was inescapable, and it was one of the greatest moments of unification in the history of science. Light was not its own phenomenon. It was this dancing, self-propagating wave of electricity and magnetism. But this beautiful revelation, this elegant solution to the mystery of light's nature, also created a terrifying and profound new problem. If the speed of light was not relative to any ether, but was instead a calculated value born from the universe's most fundamental and constant properties, then its speed itself must be a constant. It would be the same for everyone, everywhere, regardless of how they were moving. This idea made no logical sense. It was a crack in the very foundation of reality, a paradox that would require a complete rethinking of space and time themselves. What would the world look like if you could ride upon a beam of light? What would you see? What would you feel? It is a question born of pure, childlike imagination, a whimsical daydream. And yet, this very question, when asked by a 16-year-old boy who would later work as a clerk in a Swiss patent office, would ultimately unravel our entire understanding of the universe and weave it back together in a new and astonishingly beautiful way. That boy was, of course, a young Albert Einstein, and his simple, profound thought experiment would become the seed of his theory of relativity. Let us try to join him in that daydream. Let us transport our minds to a quiet, dusty patent office in the city of Bern, Switzerland, around the year 1900. The air is filled with the scent of old paper and sealing wax. The only sounds are the rhythmic ticking of a heavy wall clock and the distant, muffled clatter of horse-drawn carriages on the cobblestone streets outside. A young patent clerk, tasked with reviewing the inventions of others, finds his mind drifting away from the technical diagrams on his desk, drifting into a world of pure thought, chasing after a beam of light. Imagine yourself in this daydream. You are speeding through the cosmos, riding alongside a wave of light as if it were a celestial surfboard. You match its speed perfectly. Now, what do you see when you look over at it? According to all the physics that existed before this moment, the answer should be simple. Just as a car moving at the same speed as yours on a motorway appears to be stationary relative to you, this light wave should also appear to be stationary. You would see, frozen in space beside you, a static, oscillating wave of electric and magnetic fields, a motionless, shimmering crest and trough, fixed in place forever. It would be a beautiful, crystalline, and completely stationary sculpture of light. But here, in this quiet daydream, a profound contradiction arises, a deep crack in the logic of the universe. Because according to the beautiful, unshakable equations of James Clerk Maxwell, the very equations that had defined light as an electromagnetic wave, a stationary light wave is an impossibility. It is a logical contradiction, a violation of its very nature. Maxwell's equations state that a changing electric field creates a magnetic field, and a changing magnetic field creates an electric field. This ceaseless, self-perpetuating change is what a light wave is. A light wave that is not moving, that is not changing, is not a light wave at all. It simply cannot exist. This was the paradox that haunted the young Einstein. The laws of motion and the laws of electromagnetism gave two different, mutually exclusive answers to the same simple question. One set of laws said that the wave must appear stationary, and the other said that a stationary wave was a physical absurdity. This realization was a moment of quiet, earth-shattering genius. It showed Einstein that something was profoundly wrong, not with one theory or the other, but with our most fundamental, deeply ingrained assumptions about the nature of space and of time itself. He understood that the greatest breakthroughs in our understanding of the world often come not from a new piece of technology or a complex new experiment, but from the courage to ask a simple, imaginative question and the tenacity to follow that question wherever it may lead, even if it leads to a place that seems to defy all common sense. It is a testament to the power of a curious and untethered mind, a reminder that the universe's deepest secrets are sometimes unlocked, not with a key, but with a question. This impossible daydream, this unsolvable puzzle of the frozen light wave, forced Einstein toward a radical, audacious, and world-altering conclusion. If the light wave could never appear to be stationary, if it must always be seen to be in motion, then the only possibility was that no matter how fast you moved, no matter how hard you chased it, you must always measure its speed to be exactly the same. This strange and stubborn idea would become the unshakable bedrock of his new reality, a reality where the ultimate constant in the universe was not space, nor time, but the speed of light itself. Imagine you are a passenger on a perfectly smooth and silent train, a train so advanced that it glides along its tracks without a single jolt or vibration. And imagine that this train car has no windows, so you are completely sealed off from the outside world. Now, in the quiet, self-contained universe of your train car, you decide to toss a small ball gently up into the air. It travels straight up, pauses for a moment at the peak of its arc, and then falls straight back down into your hand. Its behavior is perfectly normal, completely predictable, exactly as it would be if you were standing still on solid ground in your living room. The laws of physics governing the ball's flight are unchanged by the train's motion. This simple observation, this feeling of normalcy inside a moving system, is the key to understanding the first great principle upon which Einstein built his new vision of the universe. Let us settle into this scene, the gentle and rhythmic feeling of effortless travel. The air inside the train car is still and calm. The lighting is soft. There is a low, almost imperceptible hum of the train's machinery, but otherwise, a profound sense of peace and stability. In this isolated world, all of your experiences are consistent and coherent. If you were to pour a cup of tea, the liquid would fall straight down into the cup. If you were to drop your keys, they would land directly at your feet. There is absolutely no experiment you could perform, confined within this windowless car, that could tell you whether you are moving at a constant speed of 100 kilometers per hour or standing perfectly still at the station. This is the heart of what is known as the principle of relativity, an idea that dates back to Galileo centuries before Einstein. It is the first of the two great postulates, or assumptions, of special relativity, and it states that the laws of physics are the same for all observers who are in uniform motion. This simply means that there is no privileged or correct frame of reference in the universe. There is no absolute state of rest against which all other motion can be measured. Let's return to our train. From your perspective inside the moving car, the ball you tossed went straight up and straight down, a simple vertical journey. But now let's imagine someone standing on the station platform outside, able to see into your car through magical transparent walls. From their perspective, the ball did something quite different. They saw the ball leave your hand, and as the train moved forward, they saw the ball travel forwards as well, tracing a long, graceful parabolic arc through the air before landing back in your hand, which had also moved forward. So, who is right? Who saw the true path of the ball? The profound answer is that you both did. Both perspectives are equally valid, equally real. Your description of a straight vertical line and the platform observer's description of a long arc are just two different, equally correct ways of describing the same event from two different frames of reference. Physics works perfectly in both. We can reflect on this for a moment. There is a deep and almost philosophical sense of democracy written into this physical law. It tells us that we each exist within our own frame of reference, experiencing the world from a unique vantage point, and that the universe honors all of these perspectives as being equally valid. There is no single, objective, God's eye view of an event. There are only the countless valid perspectives of countless different observers. This principle feels comfortable. It feels like common sense. We have all experienced it when walking down the aisle of a moving aeroplane or a train. It is the foundation of what we call classical, or Galilean, relativity. And for centuries it worked perfectly to describe the world. But this comfortable, common-sense principle is about to collide with the stubborn, unwavering fact that the speed of light is not relative. What happens if, instead of tossing a ball on this train, you decide to turn on a flashlight? This is where common sense begins to fray, where our intuition starts to shatter, and where the true, strange, and beautiful nature of our universe begins to reveal itself. If you found yourself driving a car at a brisk 60 miles per hour along a perfectly straight and empty road, and you were to switch on your headlights, how fast would the light from those beams be traveling? Your intuition, honed by a lifetime of experience in a world of tossed balls and moving vehicles, would immediately suggest an answer. You would, quite logically, add the two speeds together. You would surmise that the light must be traveling at its own incredible speed, plus the 60 miles per hour contributed by the car's forward motion. It is a perfectly sensible, rational, and logical conclusion to draw. And it is, according to the deep and strange laws of our universe, completely and utterly wrong. The universe has a different answer, an answer that defies our everyday experience and invites us into a reality that is far more wondrous and flexible than we could have imagined. Let us travel to a place where we can ponder this mystery. Picture a vast, empty salt flat at the gentle hour of dusk. The horizon is a perfectly flat line in every direction, and the setting sun has painted the sky in soft, fading colors. The air is cool and absolutely still. A single, sleek, futuristic car sits alone in the immense emptiness, a silent testament to the human fascination with speed. It is a scene of profound quiet, a perfect, uncluttered stage upon which to witness a deep physical truth. This is where we encounter the second great postulate of Einstein's special relativity, the pillar upon which his entire revolution was built. And it is this: the speed of light in a vacuum is the same for all observers, regardless of the motion of the light source or the motion of the observer. Let us unpack what this truly means. The driver inside that car on the salt flat, moving at 60 miles per hour, turns on their headlights. They have with them a fantastically precise instrument for measuring the speed of light. They point it forward and measure the speed of the light leaving their own car. The instrument reads approximately 299,792,458 meters per second, the universal constant known as c. Now, you are standing perfectly still on the salt, many miles away, and you also have an identical measuring device. As the car speeds towards you, you measure the speed of the light from its headlights. Your intuition tells you that you should measure a speed of c plus 60 miles per hour, but you do not. Your instrument reads the exact same number as the driver's. c. The motion of the car has added absolutely nothing to the speed of its light. Now, the car passes you and speeds away into the distance. You measure the light again. Surely now the speed will be c minus 60 miles per hour. But it is not. The number is the same. It is always the same. This is an idea that utterly shatters our everyday understanding of how speeds combine. If a person on a moving train throws a baseball forward, we on the platform would measure the baseball's speed as the speed of the train plus the speed of the throw. That is the world we know. But light does not play by these rules. It is not like a baseball. It is something far more fundamental. Light does not inherit the motion of its source. Its speed is an absolute, an unshakable and democratic constant for every observer in the universe. This profound and unsettling truth is the universe whispering to us that our common sense is not a reflection of universal law, but merely a set of local bylaws that happen to work very well at the slow, plodding, human speeds at which we live our lives. The true rules of reality are deeper, stranger, and far more elegant. To truly grasp them requires a kind of gentle surrender, an acceptance that the universe is not obligated to conform to the expectations we have built from our limited and parochial experience. If the speed of light is absolute, if it is the one thing in the cosmos that can never be seen to change, then something else, something we have always considered to be rigid and absolute, must be flexible. The simple equation tells us that speed equals distance divided by time. If the speed is to remain constant for everyone, then distance and time themselves must become fluid, malleable, and personal. We often speak of space and time as two completely different concepts, two separate categories of existence. We think of space as the vast, empty stage upon which the drama of the universe unfolds, a collection of places you can be. And we think of time as the invisible, relentless river that carries everything forward, a universal clock that ticks at the same rate for everyone, everywhere, a place to be and a moment to be there. But what if this separation is just an illusion of our perception? What if space and time are not a stage and a clock, but are instead individual threads that are woven together so intimately that they form a single, pliable, and responsive fabric? This is the next great leap in our journey, the conceptual shift from 3 dimensions of space and 1 of time to a unified 4-dimensional reality. Imagine an old, heavy, and beautifully made quilt laid out upon a bed. You can feel its texture, the intricate pattern of the threads, the comforting weight of it. It has its own structure, its own form. If you place a heavy object, like a bowling ball, in the center of the quilt, it sags and stretches, creating a depression, a curve in the fabric. The very geometry of the quilt has been altered by the presence of the object. Now imagine that everything in the universe, including you, is not just resting on this quilt, but is an inseparable part of its very weave. This beautiful and powerful idea was first formally proposed by one of Einstein's former teachers, Hermann Minkowski, who in 1908 declared, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." He gave this union a name: Spacetime. In this new vision of the cosmos, space is not a static background, and time is not a universal metronome. They are a single, unified, 4-dimensional continuum. Every event, from the flicker of a candle to the explosion of a supernova, can be described by a unique coordinate in space-time. Its 3 coordinates in space, its location, and its 1 coordinate in time, its moment of occurrence. The most profound implication of this union is that moving through space affects how you experience time, and vice versa. They are inextricably linked. You cannot alter your motion through one without altering your journey through the other. To keep the speed of light constant for everyone, as the universe insists we must, this unified fabric of space-time must be able to stretch and warp in response to motion. Let us return to our analogy of a large, stretchy rubber sheet. Imagine that moving purely through time is like standing still on one spot, while the sheet is carried forward on a conveyor belt. Now, imagine you decide to walk across the sheet. A portion of your motion is now directed across the sheet through space, which means less of your motion is available to be carried forward by the conveyor belt through time. Your path through this combined reality of sheet and conveyor is now a diagonal. By moving through space, you have slowed your progress through time. This is the great secret of relativity. The reason the speed of light is constant for all observers is because the very fabric of space-time reconfigures itself, stretching and compressing both space and time to ensure that this is so. It is a universe that is fundamentally cooperative, a reality that is flexible enough to uphold its most sacred law. Let us pause to reflect on this. We are not merely actors performing on a rigid, unchanging stage. We are woven into the very threads of the stage itself. Our every movement, our every passing moment, is a unique path that we trace through this dynamic, responsive, and 4-dimensional fabric. This understanding makes our existence feel far more deeply integrated with the cosmos than we might have previously imagined. We are not just in the universe, we are a pattern of motion within the very substance of the universe. We are, each of us, a unique and irreplaceable trajectory through the grand and mysterious tapestry of space-time. And if this fabric of reality is indeed a fabric, then like any textile, it can be stretched and distorted. This stretching has a profound and mind-bending consequence for the one thing we all believe we share, the one thing we assume is absolute and universal, the steady, familiar, and relentless passage of time. Imagine, for a moment, that you have an identical twin. You have shared every moment of your lives, your birthdays, your histories, your very DNA. Now, imagine that your twin is an astronaut, and they are chosen for a remarkable journey, a long voyage to a distant star system in a spaceship capable of traveling at nearly the speed of light. You say your goodbyes, and they depart, accelerating into the black emptiness of space. You remain here on Earth, living your life. The seasons turn, the years pass by, and you grow older. Finally, the day of their return arrives. Their ship lands, the hatch opens, and your twin emerges, and you discover something that seems to defy all logic and reason. While you have aged decades, your twin has aged only a few years. They are, in a very real and biological sense, now significantly younger than you. This is not a work of science fiction. It is a direct, albeit extreme, consequence of the strange and beautiful way our universe is woven together. It is a story that illustrates the profound truth that time is not what it seems. Let us follow these two twins on their separate journeys. For the twin who remains on Earth, time flows in its familiar, relentless rhythm. The sun rises and sets, the moon waxes and wanes. Friends and family celebrate birthdays, children are born and grow up, and the gentle but undeniable marks of age gather like fine dust. There is a sense of shared history, of a timeline that is common to all. For the astronaut twin, hurtling through the cosmos, the experience is entirely different. Inside their ship, time feels perfectly normal. Their watch ticks at a steady second per second. Their heart beats at a normal rhythm. But outside, the universe is transformed. The stars, once distant points of light, become streaks of blue and white. The journey that would take millennia at ordinary speeds is compressed into a matter of years from their perspective. They are living in a bubble of fast travel and slow time. The emotional distance of their journey is matched by a literal, physical, temporal distance. When they reunite, they are no longer contemporaries, but living paradoxes, a bridge between two different streams of time. To understand how this can be, we can use a beautifully simple thought experiment devised by Einstein himself, known as a light clock. Imagine a clock that consists of two perfectly parallel mirrors, with a single particle of light, a photon, bouncing endlessly between them. Each time the photon hits a mirror, it represents one tick of the clock. Now, if this clock is standing still in front of you, the photon travels a short, straight, vertical path up and down. The ticks are regular and quick. But now, let's put this same clock on a speeding spaceship and watch it fly past us. From our stationary perspective, the photon inside the moving clock has to travel a longer path. Because the clock is moving forward, the photon has to travel on a diagonal to catch up with the top mirror, and then another diagonal to catch up with the bottom mirror. The path of the photon is now a zigzag, which is clearly a longer distance than the simple up and down path of the stationary clock. And here we must remember the universe's one unbreakable rule. The speed of light is constant for all observers. Since the photon in the moving clock has to travel a greater distance, but it cannot travel any faster, it must therefore take a longer amount of time to complete each tick. From our perspective, the moving clock is ticking more slowly than our own. Time itself has slowed down for the moving object. This is not a mechanical error or a trick of perception. It is a fundamental property of spacetime, and it is a proven reality. The satellites of the Global Positioning System, the GPS, that many of us use every day, are orbiting the Earth at high speeds, and their internal clocks run slightly slower than clocks on the ground. If scientists did not constantly correct for this time dilation, the entire system would fail within hours, accumulating errors of many kilometers each day. Let us rest with this idea for a moment. Time is not a great, universal river that flows at the same rate for everyone and everything. It is a personal, private stream. The faster you move through space, the more slowly your own private stream of time flows relative to a stationary observer. Our lives are not measured by a single, cosmic metronome that dictates one single now for the entire universe. Each of us is on a unique journey through space-time, and the rate at which we experience the passage of time is intimately bound to the path we take. And because space and time are two aspects of a single, unified fabric, when one of them stretches and becomes flexible, the other must respond in kind. As you accelerate on your journey through the cosmos, not only does your clock appear to slow down, but the universe itself, the very space in front of you, appears to shrink and compress before your very eyes. Have you ever found yourself running at full speed down a very long hallway, your eyes fixed on the door at the distant end? As you run, a curious visual phenomenon occurs. The door, your destination, seems to rush towards you, growing larger more quickly than you would expect. while the walls to your side, the periphery of your vision, seem to blur and streak past. In that moment of focused, forward motion, the world seems to narrow and compress in the direction you are heading. This familiar, sensory experience is a gentle, intuitive echo of another of relativity's profound consequences, one that is the perfect counterpart to the stretching of time. Just as moving clocks run slow, the universe asserts that moving rulers must shrink. Let us immerse ourselves in that sensation of running. Feel the rhythmic pump of your arms, the steady cadence of your feet on the floor, the sound of your own breath, deep and regular. Your entire being, your entire focus, is aimed forward. The world in front of you is sharp and clear, your destination pulling you in, but the world to your sides becomes a fluid smear of color and form. It is as if the space around you is reconfiguring itself in response to your motion, sacrificing peripheral detail for forward progress. The hallway does not just feel shorter, according to the laws of relativity. From your perspective, it has actually, physically, become shorter. This is the phenomenon known as length contraction, or Lorentz contraction. It is the other side of the space-time coin. Time dilates, or stretches, while space contracts, or shrinks. This happens for the very same reason that time slows down, to ensure that the speed of light remains constant for every single observer. Let's return to our astronaut twin on their journey to a distant star. From our perspective here on Earth, the star is, let's say, 10 light-years away. We see the astronaut's spaceship moving at a tremendous speed, and we observe that their clock is ticking incredibly slowly. This slowed down time is what allows them, in our view, to cover the vast 10 light-year distance within their own shortened, subjective lifespan. But what does the astronaut experience? Inside their ship, their clock is ticking perfectly normally. 1 second feels like 1 second. From their frame of reference, time is not slow at all. So how can they possibly cross a distance of 10 light-years in just a few years of their own time? The answer is that, from their perspective, the distance to the star is no longer 10 light-years. As they accelerate, the space between them and their destination physically contracts. The entire universe shrinks in their direction of motion. The journey that we on Earth measure as 10 light-years long might be for them a journey of only 2 light-years. Both perspectives are equally valid, and both agree on the final outcome. The astronaut successfully reaches the star. We on Earth say it is because their time slowed down. The astronaut says it is because the distance shrank. It is the same event, described in the different languages of 2 different frames of reference. This reveals the deep and beautiful elasticity of our universe. Reality is not a rigid, pre-drawn stage with a fixed geometry. It is a flexible, cooperative, and dynamic entity. It will literally shrink vast cosmic distances and slow the inexorable passage of time, performing these incredible acts of cosmic gymnastics, all to uphold its single, most fundamental law, that the speed of a beam of light will always be measured as c. This is a profound shift in our understanding of existence. Space is not an empty void, but a pliable substance. Time is not a relentless master, but a flexible servant. They are both participants in the great cosmic dance, reconfiguring themselves in perfect harmony to maintain the constancy of the speed of light. Let us reflect on the quiet elegance of this. The universe is not presenting us with arbitrary or restrictive rules. It is revealing a deep, internal consistency. Time slows, and space shrinks. The universe performs these incredible feats to keep its books balanced for every observer. But this leads us to the ultimate question. If the universe makes such dramatic adjustments as you get closer and closer to the speed of light, what happens if you try to take that final step? What force rises up to stop you from actually reaching it? The answer to that question lies buried within the 5 most famous characters in the history of science, an equation that reveals the deepest and most intimate relationship between the solid stuff of the world and the pure, radiant energy of light. In the year 1905, within a flurry of groundbreaking papers that would forever change the course of human thought, Albert Einstein wrote down a short and deceptively simple statement, a quiet little equation consisting of just 5 characters. A equals mc squared. He likely had no idea at the time that this elegant, almost humble piece of mathematics, born from pure thought and written with simple ink on paper, held within it both the creative fire of the stars and the terrible, world-shattering fury of an atomic bomb. It is, without question, the most famous equation in all of science, and yet its deepest meaning is often lost in its fame. It is not just a formula, it is a poem about the universe, a revelation of the most intimate and secret relationship between the solid, tangible stuff of the world and the ethereal, radiant energy of light. Let us take a moment to be with the quiet act of its creation. Picture a hand holding a simple fountain pen, the nib scratching gently across a sheet of paper. It is a scene of profound stillness, of deep and silent intellectual concentration. Now, contrast that image with the awesome and terrifying power it would eventually unlock. The blinding, silent flash of a nuclear detonation, or the sustained, life-giving furnace burning at the heart of our sun. All of that immense, cosmic power was hidden, sleeping, within those 5 simple symbols. The equation tells us that energy, E, is equal to mass, m, multiplied by the speed of light, c, squared. At its most basic level, it is a recipe for converting mass into energy. And the key ingredient in that recipe, the thing that makes it so incredibly potent, is that c squared term. The speed of light, c, is already a colossal number, approximately 300 million meters per second. When you square that number, you get 9 with 16 zeros after it, a number so vast it is difficult for our minds to hold. This is why the equation is so powerful. It tells us that you only need to convert a tiny, almost insignificant amount of mass to release a truly tremendous and astonishing amount of energy. A single gram of matter, if converted completely into energy, would release the equivalent of the explosion of over 20,000 tons of TNT. This is the very principle that powers the sun. Deep within its core, under unimaginable pressure and heat, the sun is constantly converting a small fraction of its mass into a torrent of energy, the very sunlight that travels across the solar system to warm our world and make life on Earth possible. But the equation has a flip side, a deeper meaning that is even more crucial to our journey tonight. If mass can be converted into energy, then energy can also, in a sense, be converted into mass. The two are not just convertible. They are, at a fundamental level, 2 different aspects of the same underlying thing. Mass is a kind of hyper-concentrated, slow-vibrating, congealed energy. Energy is liberated, fast-moving, unfrozen mass. And this brings us to the ultimate reason why an object with mass can never reach the speed of light. As you take an object, like a spaceship, and you begin to push on it, you are adding kinetic energy to it, the energy of motion. The spaceship speeds up. But according to Einstein, that energy you are adding does not only increase the spaceship's speed, it also adds to its mass. As the spaceship gets faster and faster, its mass, what we call its relativistic mass, also increases. At everyday, human speeds, this increase in mass is so infinitesimally small that we could never hope to measure it. It is completely negligible. But as the spaceship approaches the speed of light, the effect becomes dramatic and overwhelming. Its mass begins to climb exponentially. As you push it closer and closer to the ultimate speed limit, its mass approaches infinity. Now, think about what it would take to accelerate an object that has an infinite mass. According to Newton's laws, to accelerate any mass, you need to apply a force. To accelerate an infinitely heavy object would require an infinite amount of energy. The universe itself, through this deep and beautiful law, stands in your way. It is not that there is a physical barrier in space that stops you. It is that the object you are trying to accelerate becomes, in effect, the entire universe's worth of inertia. The speed limit of light is not a signpost. It is a consequence woven into the very identity of matter and energy. The solid world we see and touch is made of the same fundamental stuff as a sunbeam, just bound up, for a time, in the slow and stable form we call mass. And to make that bound-up stuff travel at the speed of the unbound light would require undoing the very bonds that make it matter at all. We live our lives in a world that is governed by a simple and seemingly unbreakable rule. The arrow of time flies only in one direction. We understand, in our bones, that a glass must first be dropped before it can shatter on the floor. We know that the ripples in a pond spread outwards after a stone has been tossed into its center. We know that we hear an echo only after we have shouted into a canyon. This is the fundamental principle of causality, the law that dictates that a cause must always, without exception, precede its effect. Now, just for a moment, try to imagine a universe where this was not true. A universe where you could see the shattered pieces of a glass leap off the floor and assemble themselves into a perfect vessel that then flies up into your hand. A universe where you could receive a reply to a letter before you had even decided to write it. It is a thought that feels deeply, fundamentally wrong. It is a world without logic, a story without a coherent plot. Let us sink into that feeling by playing a familiar scene in our minds, but in the wrong order. Picture, in exquisite slow motion, a crystal glass tipping over the edge of a wooden table. You see the glint of light on its curved surface as it begins its descent. There is a moment of graceful, weightless silence as it falls through the air. You can almost feel the anticipation of the inevitable impact. And then it strikes the floor, and in an instant, it explodes into 1,000 glittering, chaotic shards. It is a short, sad, and perfectly logical story. The fall, then the shatter. Now, let us try to watch that story in reverse. 1,000 shards of glass suddenly leap from the floor, a chaotic swarm that magically and perfectly reassembles itself in mid-air, forming a flawless glass that then continues its upward journey, landing softly and securely on the edge of the table. The feeling this backward scene evokes is one of deep unease. It is uncanny, unnatural, almost magical, because it violates the most fundamental narrative structure of our reality. The speed of light is the silent, vigilant guardian that ensures the universe's story is always told in the correct order. The reason for this is that the speed of light is not just a speed limit for the travel of objects. It is, far more importantly, the speed limit for the travel of information. No signal, no message, no causal influence of any kind can be transmitted from one point in the universe to another faster than the speed of a photon in a vacuum. If it were possible to send a signal faster than light, you could engineer scenarios that would completely destroy the logic of causality. Imagine you have a device that can send a message to a distant star system, 1,000 light-years away, and this message travels faster than light, arriving almost instantly. Your friend in that star system could then immediately send a reply, also faster than light, which would arrive back to you a moment after you sent your original message. Now, imagine your message was a question, and their reply was the answer. You would receive the answer to your question years before the light from your own question could have even reached them. You could even receive a reply telling you to not send the original message, creating an impossible, self-negating loop, a classic temporal paradox. The speed of light, c, therefore, acts as a kind of cosmic law enforcement officer, a steadfast guardian that protects the logical integrity of the timeline. It ensures that the chain of cause and effect can never be broken or rearranged. It is the rule that allows the universe to be a comprehensible place, a place where events unfold in a rational, sequential order, where the past influences the present and the present influences the future. The light speed limit is not, then, a frustrating restriction that prevents us from exploring the galaxy. It is a profound and necessary protection. It is the very law that allows a coherent story of the universe to be told at all, a story where one thing logically and gracefully follows another. It is the guardian of the arrow of time, the principle that ensures shattered glasses do not reassemble themselves. And this universal speed limit, this silent protector of causality, has a beautiful and profound side effect on the way we see the cosmos. When we turn our gaze upwards to the vast, dark canvas of the night sky, we are not just looking out into the immense distances of space. We are, because of this finite speed, looking back into the deep and silent corridors of history itself. When you next find yourself under a clear and moonless night sky, far away from the obscuring glow of city lights, I invite you to look up at the scattered diamonds of the stars. And as you gaze upon their serene and steady twinkle, Consider this quiet and poignant thought. Many of the stars you are looking at may already be dead. You could be witnessing the light from a grand and silent funeral, a cosmic memorial service for a star that exhausted its fuel and ended its life in a brilliant explosion, or perhaps simply faded into darkness thousands upon thousands of years ago. The light you see tonight is the last testament of its existence, an echo that has been travelling across the void for eons, arriving here, now, to greet your eyes long after its source has vanished. The night sky is not a snapshot of the present. It is a deep and layered album of the past. Let us sink into that feeling of a truly dark sky. Picture yourself wrapped in the cool night air, lying on a soft blanket, with nothing above you but the deep, velvet black of the cosmos. The silence is profound, broken only by the gentle sounds of the sleeping world around you. And in that silence, the stars seem to burn with a special clarity, pinpricks of cold, ancient fire. There is the faint, milky wash of the galaxy itself, a luminous river of countless suns so distant they merge into a single, gentle glow. There is a feeling of immense scale, a sense of your own smallness that is not frightening, but deeply comforting, a feeling of being a tiny, conscious part of something immeasurably vast and beautiful. You feel a connection not just to the earth beneath you, but to the great, silent, and ageless ocean of the universe above. Because light has a finite and constant speed, looking out into the universe is, by necessity, looking back in time. The farther away an object is, the longer its light has taken to reach us, and therefore the further back into its past we are seeing. The effect is small for objects within our own cosmic neighbourhood. The light from Proxima Centauri, the nearest star to our Sun, is a little over 4 years old. But as we look deeper, the time delay becomes staggering. The beautiful blue-white star Rigel, in the constellation of Orion, is roughly 860 light-years away. The light we see from it tonight began its journey around the year 1165, during the High Middle Ages on Earth. And when we look beyond our own galaxy, we become true time travelers. The Andromeda Galaxy is our closest major galactic neighbour, a beautiful spiral city of stars that is visible to the naked eye as a faint, fuzzy smudge. It is approximately 2.5 million light-years away. This means the light we see from it tonight, the light that is entering your eye as you gaze at that smudge, began its epic journey across intergalactic space 2.5 million years ago. At that time, on Earth, our own distant ancestors, early hominids, were just beginning their own journey. We are seeing the Andromeda Galaxy not as it is today, but as it was in a time before our species even existed. Astronomers use this very principle as their most powerful tool, a kind of cosmic time machine. To see what the universe was like in its infancy, they build incredibly powerful telescopes, like the James Webb Space Telescope, that are designed to capture the faint, ancient light from the most distant galaxies. The light from these fledgling galaxies has been travelling towards us for over 13 billion years, carrying with it a picture of a younger, more chaotic, and very different cosmos. Each starry night is a history lesson. The sky is a grand museum, and its exhibits are the ghosts of distant suns and ancient galaxies. Gazing into its depths connects us to a timeline so vast it humbles our human scales of time, making our own lives, and indeed all of human history, seem like a brief, flickering, and incredibly precious moment of awareness in a universe of ancient, patient light. We are a momentary consciousness, born on a quiet world, privileged to be able to look up and receive these messages from a past so deep it is almost beyond imagining. But this beautiful time machine effect comes with a profound and unavoidable limitation. If we can only see the light that has had time to reach us, does that mean there is a point in the universe so far away that its light has not yet arrived? Is there a cosmic horizon, an ultimate edge to our vision, that we can never, ever look beyond? Imagine you are standing alone on the shore of a truly infinite ocean on the darkest of nights. The water stretches out before you, endless and black. Now, imagine you are in a lighthouse, and its powerful lamp sends a single, sweeping beam of light out over the waves. Within the circle of that light, you can see the texture of the water, the crests and troughs of the waves, the play of shadow and reflection. But beyond the sharp edge of that circle of illumination, there is only absolute, impenetrable darkness. You know, with certainty, that the ocean continues on out there, forever. But your vision, your personal knowledge of that ocean, ends at the boundary of the light. You are standing on the shore of the knowable, looking out at an infinite mystery. This is, in a very deep sense, the situation we find ourselves in as we gaze out into the cosmos. Let us inhabit that scene for a moment. Feel the cool, damp, and salty air on your face. Hear the rhythmic, hypnotic sound of unseen waves crashing on the shore, a constant reminder of the vast, powerful entity that lies just beyond your sight. The only other sound is the quiet, mechanical hum of the lighthouse lamp as it rotates. The beam of light is a powerful, almost tangible presence, a cone of visibility that sweeps across the dark water, revealing a small patch of reality for a moment before moving on, plunging it back into darkness. There is a feeling of solitude, of safety within the light, but also a profound and humbling awareness of the immense, unknown mystery that lies just beyond the furthest reach of your perception. That boundary, that sharp line between the illuminated and the unilluminated, is your horizon. Our universe has a horizon just like this, but it is a horizon in time, not in space. Because the universe began in a specific event, the Big Bang, approximately 13.8 billion years ago, we on Earth can only ever see the light from objects whose light has had 13.8 billion years, or less, to travel and reach us. This creates a vast, spherical, conceptual bubble around us, a bubble with a radius of 13.8 billion light-years. This is our observable universe. It is not a physical edge or a wall out in space. An astronaut traveling in a spaceship would never crash into it. It is an information boundary. It is the edge of what we can, even in principle, ever hope to see from our vantage point here on Earth. Anything beyond that bubble is simply too far away for its light to have had enough time to complete the journey to us since the beginning of time itself. But the situation is even more profound and stranger than that, because the fabric of space itself is expanding, and this expansion is accelerating. This means that very distant galaxies are receding from us at incredible speeds. For galaxies that are beyond our cosmic horizon, the space between us and them is expanding so rapidly that it is, in effect, carrying them away from us faster than the speed of light. This does not violate Einstein's theory, because it is not the galaxy that is traveling through space faster than light, but space itself that is stretching and carrying the galaxy away. The profound consequence of this is that the light from those ultra-distant galaxies is like a runner trying to run up a downward-moving escalator that is moving down faster than they can run up. That light will never reach us. It is struggling to cross the expanding space between us, but the space expands faster than it can travel. This means that there are vast, perhaps infinite, regions of our own universe, filled with countless galaxies, stars, and perhaps even other forms of life, that we will not only never visit, but will never even be able to see. Their light forever lost to us in the cosmic expansion. There is a deep and fundamental limit to what we can ever know about our own universe. We are, in a very real sense, cosmic islanders, living our lives within our own personal lighthouse beam, forever bounded by our horizon. This is not a failure of our technology or our science, but a profound and humbling feature of our existence. It tells us that the universe is not required to reveal all of its secrets to us. It leaves room for a vast and endless mystery, for the truly unimaginable. We live inside this beautiful bubble of light, a reality defined and structured by its steadfast, finite speed. But what if it were different? Let us, for a moment, engage in one final act of pure imagination. What kind of universe would we inhabit if light had no speed limit at all? What if, in some other imagined reality, when you reached out and flicked the switch on a simple bedside lamp, the entire universe, from the book in your hands to the most distant galaxy on the edge of creation, was illuminated in that very same single instant? Imagine a universe with no delay, no travel time for light, no patient journey from a star to your eye, just a sudden, absolute, and universal now that connected everything, everywhere, all at once. It might at first seem like a more perfect, more efficient universe. A world without the frustrating lag of communication, a cosmos that was completely and immediately present to itself. But as we explore this thought, we find that in losing light's speed limit, we would lose the very things that give our universe its structure, its history, and its profound and unfolding beauty. Let us try, for a moment, to truly imagine this instantaneous reality. The very concept of a sunset, that slow and gentle descent of the sun that paints the sky in a gradual wash of color, would be impossible. The sun would simply be in the sky one moment and gone the next, a binary switch from light to dark. The shadows that lengthen across the grass on a summer afternoon, those silent, moving markers of the passage of time, would not exist. An object would either be illuminated or in shadow, with no soft, shifting penumbra between. And the night sky would be an unimaginable horror. It would be a wall of solid, blinding, and unwavering white light. You would be seeing not just the nearby stars, but every star, every galaxy, every quasar, throughout all of cosmic space and all of cosmic time, all at once. The light from a star being born, and the light from that same star dying in a supernova billions of years later, would arrive at your eye in the exact same instant, superimposed on each other in a meaningless and overwhelming cacophony of information. In such a universe, the beautiful and profound law of causality, which we have seen is protected by the speed of light, would become entirely meaningless. The story of the cosmos would cease to be a story, for a story requires sequence, a before and an after. Instead, it would be a single, eternal, and blindingly bright page, with every word from the beginning and the end of time printed on top of each other. There would be no past to look back upon and learn from, because all information from all of history would be bombarding you in the present moment. The very concepts of memory and anticipation would have no physical foundation. Furthermore, the very structure of the universe as we know it would likely be impossible. Einstein's theory of general relativity describes gravity not as a force, but as the curvature of spacetime caused by mass and energy. This curvature propagates outwards at the speed of light. If gravity were instantaneous, the relationships between celestial bodies would be entirely different, and the stable, elegant orbits of planets and the grand, slow waltz of galaxies might never have formed. The delicate processes of stellar fusion in the heart of a star, which depend on a careful balance of forces and energy transport that is governed by the speed of light, would be altered in unimaginable ways. The universe we inhabit, a universe that is capable of evolving, of creating complexity, of building stars and planets, and eventually, life, is only possible because information takes time to travel. The speed limit of light is not a cosmic cage that restricts us. It is the very canvas upon which the masterpiece of cosmic evolution is painted. It is the principle that allows for a here and a there, a now and a then. It creates the space for history to unfold, for consequences to follow actions, for complexity to build up step by step over billions of years. Our slow, beautiful, and deeply historical universe is only possible because its most fundamental messenger, light, is patient. The limit is not a flaw, it is the masterstroke of the design. And so we find that the speed of light is not just a number, not just a rule that can be imagined away. It is something far deeper. It feels less like an arbitrary regulation that was imposed upon reality, and more like a fundamental property of the loom upon which reality itself was woven. And so, we arrive at a question of immense and quiet wonder. Why is the speed of light what it is? Why this specific, peculiar number? 299,792,458 meters per second in a vacuum. It is a number that has been measured with astonishing precision, defined now as an exact value. But why this value? Why was it not a little faster or a little slower? Why not a simple, round number? It seems, at first, to be a completely arbitrary feature of our universe, a random, constant, pulled from a cosmic hat. But the truth is far more elegant and interconnected, suggesting a universe that is not random at all, but one that is built upon a foundation of deep and unshakable mathematical logic. To explore this, let us picture a master watchmaker of the old school, hunched over a workbench littered with tiny, gleaming brass gears, delicate springs, and polished jewels. They are assembling an intricate and beautiful timepiece. Every single component in this watch has been crafted with breathtaking precision. Each gear must have exactly the right number of teeth. Each spring must have exactly the right tension. Each lever must be of exactly the right length. If you were to change the properties of even one of these tiny components, making a gear just a fraction of a millimeter wider, for example, the entire delicate mechanism would cease to function correctly. It would run too fast, or too slow, or perhaps not at all. The harmonious operation of the whole depends entirely on the perfect, fine-tuned calibration of its individual parts. The constants of our universe, like the speed of light, appear to be calibrated with just this kind of astonishing precision. As we learned from the work of James Clerk Maxwell, the speed of light is not, in fact, a fundamental constant on its own. Instead, its value elegantly and necessarily emerges from the interplay of two other, even deeper constants of nature. These are the electric permittivity and the magnetic permeability of free space. These are numbers that describe the very texture of the vacuum of spacetime itself. The permittivity describes how a vacuum responds to and allows the formation of an electric field, a measure of its electrical stretchiness, if you will. The permeability describes how a vacuum responds to and allows the formation of a magnetic field, its magnetic receptiveness. The speed of light is derived directly from these two values. It is what it is, because the vacuum of our universe has a specific, inherent electrical and magnetic character. It is a property of the stage itself, not just of the actors upon it. This leads to a profound realization. If the permittivity or the permeability of the vacuum were even slightly different, the speed of light would be different. And if the speed of light were different, the entire universe as we know it would be unrecognizably transformed. The famous equation, E equals mc squared, tells us how intimately the speed of light is tied to the relationship between matter and energy. A different value for c would mean a different rate of fusion in the heart of stars. They might burn out too quickly for life to evolve, or they might not ignite at all. The fine structure constant, which governs the strength of electromagnetic interactions, and thus all of chemistry and biology, depends directly on the speed of light. A different value would mean atoms might not be stable, that the chemical bonds that make up water and rocks and our own bodies might not be possible. The universe appears to be exquisitely fine-tuned for this specific value. This, in turn, opens up one of the deepest philosophical questions in all of science. Is the universe, at its core, fundamentally mathematical? Are these physical laws and constants things that we human beings discover, in the way an explorer discovers a new continent that was already there? Or are they things that we invent, elegant descriptions and models that we create to make sense of what we see? The profound, interlocking elegance of these constants, the way the speed of light is not arbitrary, but is instead dictated by the deeper properties of reality, strongly suggests that there is an inherent, pre-existing mathematical logic to the cosmos, a set of rules that exists independently of our minds. We are not writing the instruction manual, we are just, very slowly and very patiently, learning how to read it. And so, from these grand and cosmic questions about the very character of reality, let us now begin our final return journey back to where we started, to the quiet, personal, and intimate experience of light, and the simple, wondrous act of seeing. The vast universe, as we have discovered, is governed by a strict and unwavering speed limit, a cosmic constant that shapes the very fabric of reality. But the universe is not the only thing with such a limit. So too, do you. The intricate and mysterious inner cosmos of your own mind, the place from which your thoughts, your feelings, your memories, and your very sense of self arise, also operates under a profound speed limit of its own. The signals that carry the whisper of a new idea or the warmth of a cherished memory do not travel at the speed of light. They travel at a far more gentle, far more deliberate, and far more human pace. And in that slowness lies the very essence of our consciousness. Let us embark on one final, inward journey for a moment. Turn your attention away from the stars and into the quiet, warm darkness of your own mind. Try to capture the feeling of a thought as it begins to form. It is rarely a single, sudden flash. More often, it is like a gentle, internal storm gathering strength. A flicker of an idea, like distant lightning, which then triggers a cascade of associations, a chain reaction of memories and emotions that ripple through your awareness. It is a soft, intricate dance of tiny electrical sparks, a whisper of chemistry and current flowing through the labyrinthine pathways of the brain. There is a texture to this process, a sense of depth and unfolding, a story being written in the silent, living loom of your own neurology. This process is not instantaneous. It takes time. Our entire nervous system, the biological hardware that gives rise to our minds, operates on the elegant principles of electrochemistry. When a neuron fires, it sends a tiny electrical impulse, called an action potential, racing down its long, thin axon. This is not a signal traveling at the speed of light through a copper wire. It is a much more complex and organic process, a wave of charged ions flowing across a cellular membrane. The speed of these neural signals varies depending on the type of neuron, but at its fastest, it is still only around 120 meters per second. That is millions of times slower than the speed of light. There is a real, measurable delay as information travels from your senses to your brain, and then through the various processing centers that are required to assemble a coherent thought or a conscious experience. Just as our perception of the stars is a view into the past, our conscious awareness of the world is also, in a very real sense, living slightly in the past. By the time you become consciously aware of a sound or a touch, the event that caused it has already happened, and the raw data has already completed its slow, winding journey through your own nervous system. Let us reflect on this internal slowness. We might be tempted to see it as a limitation, a flaw in our biological design when compared to the dazzling speed of light or the processors in our computers. But perhaps this slowness is not a flaw at all. Perhaps it is our greatest gift. An instantaneous mind, a mind that could process the entire world at the speed of light, might be a mind that is incredibly knowledgeable, a perfect calculator. But would it have the capacity for contemplation? Would it be able to savor a memory, to mull over a difficult question, to feel the gentle, unfolding grace of a piece of music? It is the very delay in our own processing, the time it takes for signals to ripple and resonate through the complex architecture of our brains, that allows for depth, for reflection, for wisdom, and for the rich, layered, and often ambiguous experience that we call being human. Our consciousness is not a supercomputer. It is a slow, beautiful, and intricate symphony. The light from a star that is 1,000,000 years old travels across an unimaginable void to finally end its journey in your eye. There, it is met by an electrical signal in your brain that has traveled for just a few milliseconds from your retina. And in that profound and improbable meeting, in that quiet intersection of the cosmic and the neural, a moment of true wonder is born. And so, after our long and gentle journey through space and time, through the nature of light and the fabric of reality, we return to where we began, to the quiet of the evening, to the stillness of this present moment. Imagine, one last time, that you are sitting in a comfortable darkness, looking upwards. A single, unwavering point of light, a star from a time long past, sends its ancient message down to you. That light, after travelling for years or for centuries, finally falls, with an impossible gentleness, upon your face. It is no longer just a simple photon. It is now a story, a piece of history, a quiet testament to the profound and elegant laws that govern the cosmos. Let us rest here, in this final, peaceful scene. Feel the gentle night air on your skin. Allow your breathing to be slow and deep. The universe above feels less like a cold, empty void, and more like a familiar and orderly home. The light from that star is no longer a mystery to be solved, but a truth to be felt. It has travelled at its appointed speed, the only speed it could ever have, a speed dictated not by some arbitrary rule, but by the deepest character of spacetime itself. We have walked a long path together tonight, from a simple sunset to the paradoxes of twins, from the heart of a star to the inner workings of our own minds. And at the end of this path, we find a sense of deep and reassuring peace. The speed of light, we can now understand, is not a barrier in some cosmic race we are failing to win. It is the constant thread that weaves the fabric of space-time together, the very thing that makes the fabric exist at all. It is the unwavering law that protects the logical flow of cause and effect, ensuring the universe can tell a coherent story. It is the secret ingredient in the equation that reveals mass and energy to be one and the same, the law that makes the stars shine and holds the matter of our world together. The limit is not something holding light back from going faster. The limit is what light is. It is a fundamental property of reality, as essential and defining as the three dimensions of space or the forward arrow of time. It is the steady, rhythmic heartbeat of the universe. And so, let us reflect on this final thought. The universe is not a chaotic, random, or arbitrary place. It is a place of profound and silent order, governed by unbreakable and deeply elegant laws. There is a powerful and abiding comfort in knowing that we are a small part of such a grand, orderly, and beautiful structure. The constant, unwavering flame of a distant star is a perfect reflection of the constant, unwavering laws that govern our existence, from the cosmic to the personal. We are all, the stars and ourselves, held together in this single, harmonious, and deeply logical dance. As you prepare now to drift off into your own peaceful slumber, may you carry this sense of quiet wonder with you. May you feel a connection to the silent, steadfast light that fills the universe, and may it bring you a sense of profound and gentle calm. Thank you for joining me on this journey into the quiet heart of science. If you have found a moment of peace or a spark of wonder here tonight, I would be so grateful if you would like this video and subscribe to the channel for more soothing stories. It helps our small, quiet community to grow. I wish you the most restful of nights and the sweetest of dreams. Sleep well.